So hey everyone, welcome back to another video. So this is the playlist of Codeforce problem solving. It is the fifth video. So let's do a quick recap of the previous videos, the watermelon videos, conditional and modulus. Before that, string and character indexing, and after that, multi-value input and counting, and string comparison and increment decrement. So totally we are solving. So today we are solving the problem theater square. So that's the problem number one. So this is the literally one of the oldest problem on the Codeforces. So it's a classic. This problem is going to introduce us to something crucial. So the math based thinking division with ceiling. So the very important C++ concept called data types and overflow. So let's get into it. So this is the problem that it is 1A theater square. So the very first problem ever on Codeforces. So it's been around since the platform launched and has been solved millions of times. So being able to solve it cleanly is a rite of passage. So the theme is straightforward. You have a large rectangular square in a city and you need to pave it with a square flagstones. How many flagstones do you need? So it sounds like simple division problem, and it is, but there is a subtle trap that catches almost every beginner the first time. So we are going to walk through the trap carefully so you never fall into it. So let's read the full problem statement. So here's the full problem statement. So the problem statement is, the theater square in a capital city of Berlin has a rectangular shape with the size n and m meters. So on the occasion of the city's anniversary, a decision was taken to pave the square with the square granite flagstones. So each flagstone is the size A cross A, that means it should be a square. So what is the least number of flagstones that is needed to pave the square? So it is allowed to cover the surface larger than the theater square, but the square has to be covered. It's not allowed to break the flagstones. The sides of the flagstones should be parallel to the sides of the square. So first let us see here that what is the minimum number of flagstones needed to pave the theater square should be the answer. So now let us see the input. So a single line with three integers, that is n, m and a. The input contains three positive integer numbers in the first line, n, m and a. So n and m are the dimensions of the square in the meters. So it may be length and width. So after that, a is the size of each flagstone. So let us see the constraints here. So this is the constraint, that is 1 less than or equals to m, n, m and a, and these are within the range of 1 to 10 power 9. So this is the range. So the output should be the needed number of flagstones. A single integer, the minimum number of flagstones that is needed. So first let us look at the sample. So it is 664. After that, the output is 4. So let us visualize this that we have a 6 cross 6 square. Our flagstones are 4 cross 4. So along with the 4 meters, 6 meters, one is 4 cross 4, that squares 4 meters. So the remaining is 2 meters. So the 2 meters need to be covered. So we need a second flagstone. Even though it will be cut, that's a 2 flagstone along one side. So the same logic along the height. So 2 flagstones along the other side. So the total flagstones are 2 cross 2, that is 4. So after that, now here's the key inside. Why 2 flagstones along each other side? And it is not 1.5 because you cannot use half a flagstone. So you always round up. Even if you only need a tiny silver, you need a whole new flagstone. So this is called ceiling division. So that's the mathematical core of this problem. So let us try to build the logic of this. So let me open Notepad. So let's think through the math carefully along the n dimension. How many flagstones we need? First, we need n by a flagstones. It is not rounded but not down. Okay, so for that, first, so n by a flagstones we need. So after that, for m, we need m by a flagstones we need. So the same thing for n and m. So the total flagstones, I can say that the total flagstones is n rounded up up to a, okay. So n rounded up to a. So let me increase the size, plus it is multiplied by m rounded up to a. So this is the total. So here now how do we do ceiling division in C++? So in C++, when you divide two integers, it will be automatically does the floor division. So it rounds down. So 6 by 4, that is, if you do for example 6 divided by 4, that time you will get 1 times of 4 and the remainder should be 2. So here we got 1 as the value. So in C++, we should get 1.5 or 2. So but we need ceiling, that is round up. So how? Let us see. There is a beautiful mathematical trick is there. For the ceiling division, we have to do n plus a minus 1 divided by a. So this is how we doing ceiling division in here. That is the mathematical trick. That is the a value is n plus a minus 1 divided by a. So let's verify it. So for that, let me give the value of n is 6 and a is 4. So now if I run it here, that is n value is 6. So 6 plus 4 minus 1. So after that, it is divided by 4. So first we have to calculate within the parenthesis, that is 6 plus 4 minus 1. So as you can see, we have 6 plus 4 minus 1 value is become 3 here. So 6 plus 3, that is 9. So the 9 by 4 division will give the value of 2. So as you can see, we got the value of the ceiling division. So this formula always works for positive integers. So memorize it. So ceiling division comes up constantly in the competitive programming. So as you can see, this is the division for ceiling division. So now we have to add, this is the ceiling division of n by a and ceiling division of m by a. So to solve that, we can simply do n plus a minus 1 divided by a will be added with m plus a minus 1 divided by a. So using this, we are multiplying here. We are not adding because we have calculating the flagstones in a square manner. So for that we are doing multiplication. So this side and this side, that is height and width. So here this is the simple formula, we are going to do that. So let's see that there is a overflow trap is here. So first look at the constraints here. So as you can see, the constraint is 1 to 10 power of 9. So an int is 32 bits. So it can hold up to the value of about 2.1 multiplied by 10 power of 9. So an integer variable can only hold 32 bits, that is this value. So the 10 power 18 is way larger than the value, that is 2.1 10 power 9. So if we use int, our answer will overflow. So it will wrap around the completely wrong number. Why? Because this is 10 power 9 for this value and 10 power 9 for this value. So it should be greater than 10 power 9. So that time we are doing multiplications here. So if we use int, our answer will overflow. It will wrap around to completely a wrong number. So this is one of the most common bugs in competitive programming. So the logic is perfectly correct, but the data type is too small to store the answer. So the answer is now will store with the garbage value. So how to fix it? So instead of using integer, we can use long. So a long is 64-bit and it can store the values up to 9.2 multiplied by 9.2 multiplied by the value of 10 power 18. So this is the size of the long. So that is more than enough for the 10 power 18. So always check your constraints. If the answer could exceed 2 times of 10 power 9, so that time you have to use long. So this is a rule you must never forget. So now let us move on to the coding section. So as you can see, this is the basic setup. So create a new file in your compiler, and this is the basic setup. We'll see how to write the code line by line. So if you are not familiar with this setup, go and watch the previous videos. In those videos, I will explain every line. So now let us move on to the writing of the code. So first there is a input containing 3 variables n, m and a. So first we declare n, m and a. We declare 3 variables. After that we get input from the user, that is int n, m and a. Let me give some space. So I got 3 values n, m and a. We declare 3 variables. So I don't want it to be integer, because as we can know that it could reach the size over the integer. So for that I am using long here. So now we are using long to store it, not int. Even though in the individual inputs values fit in the int, they are most 10 power 9. So we declare them as long from the start for the safety and the consistency. So after that, this line will read all 3 inputs with the space separated values in one statement. The same chained input technique from the team problem. So notice we read all 3 on a one line, because the problem gives them one line dot cn. So that time the cn handles this perfectly. So after that we have to found next line of code, that is we have to found the value. So for that long. So now I can just name it as rows for my sake, and we just do the formula n plus a minus 1. After that it is divided by a. So this calculates how many flagstones we need along with the n dimensions for the number of rows. So this is our ceiling division formula. So let's break it down. So first what will happen, the a minus 1 to before dividing. So this is a trick that forces the division to round up instead of round down. So after that divided by a is integer division by a. So that time we will get the rounded value. So why does this work? So think about it in this way. So the normal integer division truncates, drop the remainder. So by adding a minus 1 before dividing the value, so we ensure that any remainder, even if it is just 1, it will be pushed into the next whole number. So if n is perfectly divisible by a, adding a minus 1, then dividing still gives the correct result. So the remainder from the added amount gets absorbed. So we store the result in a long called the rows. So next I will calculate for the columns, that is m. So long columns, that is m plus a minus 1 divided by e. So the exact same formula for the m dimensions, the columns, the how many flagstones do we need to cover the m meters with the flagstones of size a. So we store this in columns. So now we have to just multiply and print it. So for that, see out. So rows, after that it will be multiplied by column. After that next line. So we multiply row by column to get the total number of flagstones, and we are printing it. So since both rows and columns are long, so there will be no error. So this will not also overflow. So this is a critical. So if we had stored them as a int, even though each individual value might fit, the product could be overflow. So that time this one line of output will be clean and direct. So let us deep dive into why the ceiling formula works. So let me prove once again why it will always give the ceiling value. So any integer n can be written as, so let me write here. So any integer n can be written as q multiplied by a plus r. So where q is nothing but quotient, after that the r is nothing but remainder. Okay, q is quotient, the value that we are getting, and this is the remainder. So now let me take for the case 1, let me give the remainder as 0. So that time n is perfectly dividing by a. Okay, the ceiling of n by a will become q. So now let me write one more thing, that is if first n, the formula is n plus a minus 1 divided by a. So this is the formula here. So if you do that, we will get the quotient of that. So for getting this quotient, we can do one more thing, that is quotient is multiplied by a. So now the remainder is simply 0. Okay, we are getting the n values quotient multiplied by a and the remainder is 0, and we are subtracting the value is a minus 1. After that we have to divide it by a. So this is the formula. So in this formula, instead of n, I am replacing the n with q multiplied by a plus r. So the q multiplied by a plus the remainder is 0 currently. So now it's still q multiplied by a. So for 0 there is no value. So we just need to remove this 0. So as you can see, q multiplied by a plus a minus 1, and it is divided by a. So after that, now if I want to check the next equation, in this, as you can see that I can simply write this equation as q plus a minus 1 divided by a. So now if we do that, we will get q plus 0. So the q plus 0 is q. So now as you can see, the integer division drops the remainder. So when we do that, we get the output perfectly. So if n is greater than 0, n is not perfectly divisible by a. So that time if we do that, we will get the integer division, the value of q plus 1. That is nothing but the ceiling division. So now, because if the remainder is 0, no value will be added, q will be directly remainder. So if the value is not 0, other than that, that is greater than 0, that time we will get the value greater than 0. So let us try to solve this problem. So let us give the input values, that is 664. This time we have to get the value of 4 here. So now let us run this. So now I give the values. So I am getting the value 4 as the output. So 4 is the output. So as I can say that from this sample input output, I can say my code is perfectly working. So now let us trace how this code is working. So let me open Notepad here. So open it. So within this, I'll remove this. So let me give the value n as 6, m as 6, and a value is 4. So now I have given rows. So within these rows, we are calculating the value 6 plus 4 minus 1, and it is divided by 4. So if we do that, first we have to do this operation. So while we are doing this, as you can see, it is 3. So 3 plus 6 is 9. So let me remove this. I can simply do here, that is 6 plus 3. So 6 plus 3 divided by 4. So after that 9 divided by 4, and the value is 2. Because we are doing integer division, so we are getting the value as 2. So after that the columns, so the value of m is also 6. So 6 plus 4 minus 1, and it is divided by 4. So the same equation, we will get the same output, that is 6 plus 3, and it is divided by 4. So we will get the value, that is 9 divided by 4, the same value, that is 2. So if you multiply these two, that is 2 multiplied by 2, we will get the square, that the area of square that is being covered by this. So that time 2 multiplied by 2 is the value of 4. So now we can see that we get the value. So let also test the edge case for it. So let me give the value of n as 1 and m as 1 again. But for a, I'll give the value of around 9 zeros. So for this test case, for the rows is I have to add 1 plus 10 power 9 minus 1. So both will be cancelled. So the value will become minus 1 and plus 1 will become cancelled. So the value is 10 power 9. So for the columns also it will become the same. So if you multiply these value, so I can simply say this is nothing but 10 power 9 and this also 10 power 9. So if I multiply both values, I'll get the value of 10 power 9 multiplied by 10 power 9, I'll get 10 power 18. So this can't store within the value of integer, so that's why we are using long. So we have seen this. So now let us check this same input here, that is first 1 and 10 power of 9. Let me give. So it shows the value that is 1 because the 1 is nothing but the tiny answer. So if you go on to that, we are doing one more thing, that is we have to divide here. So that time instead of this we will get the value 1, and if I divide the same value, so that time also I will get 1. So 1 multiplied by 1 we get the value that is 1. So at the minimum case, if it is 10 power of 9 and so when it will go out of flow is, instead of this I give 10 power 9 for this both n and m and give the value of as1. So if I give that, I have to do 10 power 9 and after that plus 1 minus 1 and it is divided by 1. If I do this, I will get 10 power 9 here, and for the same thing I will get the value for the columns. So 10 power 9. So this time it is 10 power 18. So when I give here, previously I have mistakenly said that it is not dividing by that because I forgot to divide this ceiling value. So if you divide this, so that time you will get the value. So if you don't divide, you won't get the value. So for the ceiling finding division, you have to divide it with the value of a. So that time if you give n as 10 power 9, m as 10 power 9 and the value of a is 1, you will get 10 power 18, which will overflow. So now let us check here, that is 10 power 9. So I can give like this, I'll write 1e9, so it won't work. So let us give the value, that is 1e9, 1e9 and 1. So it is not working. 3, 4, 5, 6, 7, 8, 9. So if I do that, I am getting the value that is 10 power 18. So for now, if instead of long, if I give integer here and integer here, so that time we are directly multiplying instead of printing it. So let us try to run the same code. So now check. So see here, it is giving the negative value of some garbage values because we are using integer here. So integer can't hold the value of that. So we are going to give long again. As you can see, if you give integer, so the data type of integer cannot hold the value of 10 power 18. So that time we have to do something, that is changing the data type into long. So now let us run and give the same values. So I am getting the value. So now let us copy this code and go to the submit page and paste it here and make sure that you are choosing the correct language and the correct question. So after that, verify you are a human. After it shows success, just submit the solution and wait for a few minutes to run all the test cases and show this solution accepted like this here. So if you see this pop-up accepted, that means the solution is being accepted. So that's all for it. So we have solved 5 out of 5 problems correctly. So today we have packed with some important lesson, that is first ceiling division, that is the n plus a minus 1 divided by a gives the ceiling of n. So after that the integer overflow and the long values that it can only hold up to 2 power of 10 power 9. So when it is exceeded the 2 power 10 power of 9, we have to use long. So after that the estimating the answer size. Before writing the code, ask yourself what is the biggest possible output and multiply the maximum input values mentally. So if it is exceeded 10 power 9, use long. After that, math first thinking. Think the problem had no loops, no strings, no complex logic, just a single mathematical formula. Many Codeforces problem are pure math. Train yourself to look up for the formula before reaching for a loop. So reading constraints are carefully. So because here they have given 1 to 10 power of 9. So the single line told us everything about the data type we needed. So never skip the constraint section. So one more challenge for you. So what if the flagstones rectangular instead of square? So they have given that the flagstones are square because A cross A. So get size A cross B instead of A cross A. So modify the solution to handle this. You are getting 3 inputs. Make sure that you are getting 4 inputs. So that is the input I can give. That is a hint for this problem is you will need 4 input variables, that is n, m and a and b. So the size of a and b is nothing but the rectangular dimension. So and the formula changing slightly for each dimension. So try it yourself and drop your solution in the comments. So bonus points if you test it with the edge cases where the rectangle fits perfectly. So and that's all for this theater square. So the solution has been fully explained, proven mathematically and submitted. So 5 problems down. You now have a real toolkit: conditional strings, loops, counters, string comparison, ceiling division and data type awareness. You are not just solving problems. You are thinking like a programmer now. So in this next video, we will keep climbing to the another topic and another concept. So if this playlist is helping you on your competitive programming journey, please like the video, subscribe and share it. So it means the world and help the channel to grow. So comment below, had you heard of integer overflow before today, or did the video catch you by the surprise? So I'd love to know. So see you guys. That's all for this video.